Welcome to Basic Electrical Engineering lecture series. This is a series of lecture videos for the first year engineering and electrical diploma students. In these videos, fundamentals of DC and AC circuits, network theorems, fundamentals of transformers, DC and AC machines, and renewable energy sources are the topics covered. Sufficient number of numericals are worked out in each session to make the concepts clear to the viewers. For a basic idea about the topics mentioned, please watch these videos from the very beginning itself. If you find the videos useful, please subscribe for the channel, like the video and press the bell icon for notification. Please try to wear a headphone and watch the video for better sound clarity. Thank you all. And now let's start with today's session. So this is the second session in the electrical engineering lecture series. So in this session, the topics covered are Kirchhoff's laws, mesh and node analysis. Kirchhoff's laws, mesh and node analysis. So we'll start with the Kirchhoff's law. So Kirchhoff's current law, it states that at a junction, the sum of incoming currents is equal to the sum of outgoing currents. Or as stated here, the algebraic sum of currents meeting a point is zero, or the total current leaving a junction is equal to the total current entering the junction. Say for example, here see the figure 1. So this junction, I'll take it as A. The incoming currents are 10 ampere and 5 ampere. There is one outgoing current, it is 8 ampere. So sum of incoming currents 10 plus 5, 15 ampere is equal to, in this branch, I'll take the current as an outgoing current X. So the sum of outgoing currents is X plus 8. Therefore, X is equal to 7 ampere. So I got a positive value for X. That means it is an outgoing current only. Its value is 7 ampere. So incoming currents, when we add, we'll get 10 plus 5, 15. Outgoing currents, 8 plus 7, 15. Another example. Again, 10 and 5 ampere, two currents are coming to the junction A. Here, 10 ampere, this is 5 ampere. So a current of 18 ampere is going out of junction A. Again, I am assuming an outgoing current of X ampere. So adding sum of incoming currents is equal to sum of outgoing currents. So incoming currents are 10 plus 5, 15 is equal to outgoing currents X plus 18. So X is equal to, we'll get 15 minus 18, that is minus 3 ampere. That means the assumed direction of X is not correct, because while solving, adding the, while comparing the left and right hand sides, left hand side the sum of incoming currents is equal to 15 ampere, right hand side it is X plus 8. So while solving for X, we will get it as minus 3 ampere. That means the assumed direction is not correct. So this is in the opposite direction. That is also an incoming current of 3 ampere. So while now, if we add all the incoming currents, it is 10 plus 5 plus 3, 15 plus 3, 18 ampere. Outgoing current is also 18 ampere. Say another example. Here a current, here in this branch, a current of 5 ampere is coming to junction A. In this branch, current is not given. There is a 10 ohm resistor and the voltage drop across it is 10 volts. Current is not given. Current we can find out. So current in this branch is 10 volt divided by 10 ohm, that is 1 ampere. Now what is the direction? Is it an incoming current or is it an outgoing current? So it is an incoming current because the voltage drop across the 10 ohm resistor has got a positive polarity here. That means current entering terminal is positive, so the current is 1 ampere entering this terminal, positive terminal. So here also a 5 ohm resistor, across that the voltage drop is 15 ohm, 15 volts. So the current is 15 by 5, 3 ampere. So this is an outgoing current. 15 by 5 is 3 ampere. 3 ampere is going away from junction A. So now to find out the current, I'll take it as an outgoing current X. So this is incoming, this is outgoing, this is also incoming. So incoming sum of incoming currents 5 plus 1 is equal to X plus 3. So X is equal to 6 minus 3, 3 ampere. So this is an outgoing current only, which is equal to 3 ampere. So we'll check again. So in this branch, the incoming current is 5 ampere. This is also an incoming current 1 ampere. That is sum is 6 ampere. Here it is an outgoing current of 3 ampere. This is we are assuming that this is an outgoing current which is X ampere. So incoming current 5 plus 1, 6. Outgoing current sum X plus 3. So X is equal to 6 minus 3, 3 ampere. Now next is Kirchhoff's voltage law. So the law states that in a closed path or mesh, the algebraic sum of the products of currents and resistances in each of the conductors plus the algebraic sum of EMFs in that path is 0. So in a closed path, we'll assume a closed path in this figure. A, D, C, B, A. It is a closed path. The direction I'll mark. So in the branch DC, it is from D to C. In the branch BA, it is from B to A. That is the orientation of the loop or the closed path. So in a closed path, we have assumed one closed path here. That is ADCBA. In this closed path, the sum of EMFs and the products of currents and resistances. So products of currents and resistances, we'll take it as, we'll call it IR drop. Product of current and resistance, it is a voltage only. So we call it as IR drop. So in this loop, the sum of EMFs and IR drops, it should be equal to 0. So we have to add these quantities with proper sign. So the sign convention is for EMF source, rise in potential is given a positive sign. This is an EMF drop, say E1. This is the direction of the path or closed path or loop. Loop is oriented from negative of the battery to the positive of the battery. So it is a rise in potential. That means the loop is from negative of the battery to the positive of the battery. Assume negative is at zero potential, positive, say, take 10 volt. So the loop is from negative terminal of the battery to the positive terminal. So it is a rise in potential. So negative terminal we are assuming is 0 volt and positive terminal plus 10 volts. So 0 to 10 it is a rise in potential. So if this is the direction of the loop, then E1 should be given a positive sign plus E1. So rise in potential. Say same example we'll take same say E1 0 10 volt plus minus. If this is the direction of the path, so in the direction of the path, closed path or in the direction of the loop, here it is from positive terminal to negative terminal of the battery. So in this case, it is a fall in potential. So it should be given a negative sign. So while writing the equation for the loop, a rise in for EMF sources, a rise in potential should be given a positive sign and a fall in potential should be given a negative sign. That is the sign convention for EMF sources. And for IR drops, here what are the IR drops? So in the branch DC, a current of I1 is assumed. So I1 is in the direction of the loop. So for IR, the IR drop in this case is I1 R1 because the current through resistor R1 is I1. So the product is I1 R1. So what is the sign to be given to I1 R1? So sign to be given to I1 R1 is if current direction is same as loop direction, then it is a negative sign. Current direction same as loop direction. So in this case, current it is from D to C. The loop is also from D to C. Both are of the same sign. So this should be given a negative sign. Then the next voltage IR drop is I2R2. So I2R2 current direction. Current is from A to B and the loop is from B to A. Loop is in clockwise direction. So the loop is from B to A. Current is from A to B. The directions are opposite. So it's to be given a positive sign plus I2R2. Or you can say when I1R1, the IR drop I1R1 has got a polarity like this. This is the terminal at which current is entering. So the IR drop will have a positive polarity here and a negative polarity here. So in the direction of the loop, it is a fall in potential. That also you can take. So I2R2 current entering terminal, this is positive, this is negative. So in the direction of the loop, it is a rise in potential. It is going from negative to positive. So it should be given a positive sign. So in this case, the EMF source, what is the polarity of the EMF source? What is the sign to be given to the EMF source? That is, E1, it is from positive to negative. So it's a fall in potential, it is minus E1. So the equation for this loop ADCBA is minus E1 minus I1R1 plus I2R2 is equal to 0. Minus E1 plus I1R1 minus E1 minus I1R1 plus I2R2 is equal to 0. That is the first equation. Then let's take the next loop. That is, this is for the loop A, B, C, B, A. Next loop is A, B, F, E, A. That is the second loop. So let's mark the loop. So it's also in the clockwise direction. Now I'll mark what are the IR drops in this loop. The IR drops are one is I2 R2. So I2 R2 polarity is current is from A to B. That is I2 is from A to B. The loop is also from A to B. In this case, this is the second loop. The loop is from A to B. Current also from A to B. So both are of the same sign. So minus I2 R2. Loop direction same as current direction. Current is from A to B. Loop is also from A to B. Both are in the same direction. So the IR drop is to be given a negative sign. Then what is the magnitude of IR drop in R3? And before that, we have to mark the current through R3. So a current of I1 is coming to junction B. This is I1. A current of I2 is coming to junction B. So what should be the current from B to F? That is from C, a current of I1 is coming to junction B. From A current of I2 is coming. So in this branch, it should be an outgoing current, which is equal to I1 plus I2. So I1 plus I2 is the current passing through resistor R3. So the IR drop is I1 plus I2 into R3. I1 plus I2 into R3. So what is the sign of it? I1 plus I2 is from F to E. The loop is also from F to B, F to E. Both are in the same direction, so a negative sign. So I2 R2, I2 and the loop both are in the same direction, so negative sign. Here I1 plus I2 into R3. Oh, current is I1 plus I2, which is from F to E. Loop is also from F to E, same direction, so negative sign. What about the sign of E2? E2 is from negative to positive, so rise in potential, so plus E2. So the equation for the loop ABFEA is equal to E2 minus I2R2 minus I1 plus I2 into R3 is equal to 0. This is the second equation. So we got two equations. We can solve that and solve these equations and find the values of I1 and I2. So I1 is the current through R1, I2 is the current through R2, I1 plus I2 is the current through R3. So we'll get currents in all the resistors or all the branches. Now one example. So the question is using Kirchhoff's laws, find the currents in different branches. Also find the potential at B with respect to ground E. This is the ground point. E is marked here. This point is also E. Both are the same point only. Or we can, if you draw a line like this, then this corner can be avoided. So E and this point, there is no element connected between these two, so both are the same point only. So the circuit given is there's a 10 volt source, a resistance of R1 here, a resistance of R3, then resistor R2 magnitude 20 ohm. This is resistor R4 magnitude 10 ohm. This is a 20 volt source. Now, first step is to assume currents in different branches. So, a current of, we are assuming that a current of I1 is, its direction randomly you can assume. Whichever direction you want, you can assume. So, a current of I1 is assumed here, supplied by the 10 volt battery. So, through this branches, that is EA and AB, the current is assumed is I1. The 10 volt source is supplying the current, it is from A to B. So at junction B, a current of I2 is flowing to ground through resistor R3, I2. So this current, I'll take it as I3. So what is I3 in terms of I1 and I2? We'll add the incoming and outgoing currents and equate them. So incoming currents are I1 plus I3. Outgoing current is I2. I1 is an incoming current. I3 is an incoming current. I2 is an outgoing current. Therefore, I3 is equal to I2 minus I1. So instead of I3, we can write I2 minus I1. So current through R1 or 25 ohm resistor, it is I1. Current through R3 is I2. Then two more resistors are there, R2 and R4. Current through R2 is I2 minus I1. So current through R4 is also I2 minus I1. Take it. Current of I1 is coming here. A current of I2 minus I1 is coming here. So the outgoing current is sum of that, that is I2. I1 and I1 cancels. I2 is coming down. I2 is here, it is getting divided. I1 is flowing left and I2 minus I1 is flowing right to resistor R4. So we assumed currents in all branches of this network. Now we'll write the loop equations. First loop is EABE. First loop is EABE. I'll mark it. EABE. This is the loop. Loop is in clockwise direction. Now, what about how many EMF sources are there in this loop? There is only one, which is the 10 volt source. The loop is oriented from negative to the positive terminal of the battery. So it's a plus sign. So it is to be given a plus sign. So plus 10 volt. Then the remaining are IR drops only. The first one is I1 R1. Oh, R1 value is 25. So the IR drop is 25 I1. 25 I1. Plus sign or minus sign. Current is from A to B. Loop is also from A to B. So both are in the same direction, so a negative sign. Then third one is the next IR drop is I2 R3. R3 is 15 ohms. So the IR drop is 15 I2. And sign I2 is from B to E. The loop is also from B to E. Both are in the same direction. So a negative sign is equal to 0. The next loop is B, C, D, E, B. B, C, D, E, B. So start from with branch BC. So there is an IR drop, that is I2 minus I1 into R2. Sorry. I2 minus I1 into R2. What should be the sign of that? The current I2 minus I1 is from C to B, but the loop is from B to C, opposite. So plus sign. So I2 minus I1 is from C to B, loop is from B to C. So it should be given. The IR drop is 20 into R2 is 20. 20 into I2 minus I1. The sign should be positive. So here next is the 20 volt source. So the loop is from positive to negative, though it's a fall in potential. So it is minus 20. Then the next IR drop is I2 minus I1 into R4. R4 is 10. 10 into I2 minus I1. So the current I2 minus I1 is from E to D, whereas the loop is from D to E, opposite direction. Current is from E to D. E to D. Loop is from D to E, opposite direction. So a plus sign. Next. Next IR drop is 15 I2. So I2 is from B to ground, downwards. The loop is upward, ground to or E to B, opposite direction. Current direction is opposite to loop direction. So plus 15 I2 is equal to 0. This is for the loop B, C, D, E, B. Now we have to simplify these equations. First equation, when you simplify it, 25I1 plus 15I2 is equal to 10. Second equation, 20 into I2 minus I1 expanded and simplify it. It will be minus 30I1 plus 45I2 is equal to 20. Now write in matrix form. So 25, 15 minus 30, 45 into I1, I2 is equal to 10, 20. Now I1, I2 is equal to inverse of this matrix, 25, 15 minus 30, 45 inverse into 10, 20. So inverse of this matrix is given here. So I1 is equal to I1, you can write it as I1 is equal to, so inverse of this matrix is 0.028 minus 0.0095, etc. 0.0190, 0.0158. So I1 is equal to 0.02857 into 10, 0.02857 into 10 minus 0.009523 into 20. So it's equal to 0.09523. 9523 ampere. Then I2 is equal to 0.019047 into 10 plus 0.015873 into 20 is equal to 0.50793. Okay. So this gives the values of I1, I2. Then the current through the other branch is I2 minus I1. It is 0.4127. So we can mark the currents. I1 is 0.09523. I3 is, this current is 0.4127 ampere. I2 is 0.50793. These are the currents in different branches. You can check it. 0.09 is coming to junction B. 0.412 is coming to junction B. If we add it, we will get 0.507. That is the outgoing current from junction B. This is from B to ground. So the next part is to find the potential at B with respect to ground D. Potential at B with respect to ground D. This is also ground only. Now, potential, to find the potential at B with respect to ground, I'll mark a path from ground to B. So add all the voltage IR drops and EMF values in that path with proper signs, we'll get the potential at B. So this is, we'll start from this point, that is ground. Ground potential is 0, 0. Now what is the, this is the direction of the path which we have taken from between E and B. So in the direction of the path, it's a rise in potential because the path is oriented from negative to positive of the 10 volt battery, that is plus 10 volt, plus 10. Then this current I1 and this path both are in the same direction. So minus 25 IN. The IR drop is 25 I1 and its sign is to be given as negative because current direction, path direction both are same. Is equal to, that is the potential at B. So VB is equal to, with respect to ground, 0 plus 10 minus 25 I1, that is 10 minus 25 into 0.09523. This you will get it as 7.62 volts. Then you can find out the potential at B directly by taking a path from ground to B directly. So again we'll start VB is equal to 0 plus, sorry, 0. We have to find out the direction of this IR drop. I2 is opposite to the direction of the path. So it is to be given a positive sign plus IR drop value is 15 into 0.50793. 0.0793 is equal to, again you will get it as 7.62 volt. Or by taking the third path, again you can get the same answer. That is, the current in this branch is 0.414127. So the IR drop is 10 into 0.4127. So it's to be given a negative sign, minus 10 into 0.4127, because current direction same as the direction of the path. Then here the 20 volt source, the loop is oriented from negative to positive. Loop is like this. Battery potential, battery voltage, if you see negative polarity here, positive here, so it's a rise in potential plus 20. Then here current direction same as the direction of the path, so negative sign, minus 20 into 0.4127. Again you will get it as 7.62 volt. So irrespective of the path we take, we should get the same potential at B. We have considered all the three paths available between B and D. Here we got 7.62. Here also the same value, 7.62. By considering the path EDCB, again we got 7.62. So next example is we have to solve the given problem by mesh current method. Assume a mesh or a closed loop. Here two closed loops we can assume, EABE and BCDB, BCDEB. So in this loop I am assuming a current of I1. In this loop I am assuming a current of I2. Same principles you can use, apply here also. Here the two loops assumed are two. The first mesh is EABE and the current flowing through that mesh is I1. The second one is EBCDE or BCDEB, either way. The current through that mesh is I2. So again writing the, here in this case all IR drops can be considered negative because the direction of the loop and direction of the current are same. It's mesh current only. So the direction of the loop and direction of the current both are same. So we'll start from with this 10 volt source, that is in the direction of the mesh it is a rise in potential, so it is 10 plus 10. Then the current in this mesh is I1, that means current flowing through resistor R1 we have to consider it as I1. So 25I1 is the IR drop. It is negative minus 25I1. Then this R3, there are two currents. I1 is from B to E. I2 is from E to B in opposite directions. So the current in through resistor R3, while writing first mesh equation, you have to take it as I1 minus I2. The resistor value is 15. So I1 minus I2 into 15, and it is to be given a negative sign, equal to 0. So the IR drop produced by I1, it has got this polarity. It is a fall in potential. IR drop produced by I2. I2 is flowing like this. That is from E to B. So the IR drop will have opposite sign. That is why. So 15I1 has got a negative sign. 15I1 has got a. If you expand this equation, 15I1 has got a negative sign. Because in this case, it is a fall in potential. Whereas 15I2 has got a positive sign. In this case, it is a rise in potential. Or you can take the net current through that resistor is I1 minus I2 with a negative sign. So this is the first mesh current equation. The second one will start with say here. So while writing second mesh current equation, current through the 15 ohm resistor, take it as I2 minus I1. I2 minus I1 into 15, give a negative sign. So in this case, 15 I2 has got a negative sign because the IR drop produced by the current I2 is this polarity. It is a fall in potential in the case of the second loop, but I1, it is a rise in potential. So 15I2 has got a negative sign, whereas 15I1 has a positive sign. So we have to take the net current, we have to take the current through the resistor R3 by writing second mesh equation. It is I2 minus I1 into resistor value 15. So minus 15 into I2 minus I1. Here then minus 20 R2 minus, minus 20 I2. 20 I2. Then this is a fall in potential, minus 20. This is then 10I2 is equal to 0. So while the second equation, that is 15 into I2 minus I1 minus 20 I2 minus 10 I2 fall in potential 20. Simplify it, minus 15 I2 plus 15 I1 minus 20 I2 minus 10 I2 is equal to 20. So it is 15 I1 plus 15 I1 minus 45 plus 15 I1 minus 45 I2 is equal to 20. That is the second equation. First equation can be simplified to 40 I1 minus 15 I2 is equal to 10. So two equations we have got. That is first equation simplified to this is the first mesh equation. This is the second one. So first equation is simplified to 40 I1 minus 15 I2 is equal to 10. Second equation is simplified to 15 I1 minus 45 I2 is equal to 20. So it can be written in matrix form. In I1 and I2 can be found out by I1 I2 is equal to 40 minus 15, 15 minus 45 inverse into 10, 20. So I1 you will get 0.09523, I2 is minus 0.412698. So current through R1 is I1, current through R1 is 0.09523. So I1 is 0.09523. I2 is minus, so the assumed direction is not correct. Assumed direction is opposite. So this is the direction we have assumed, but we are getting a negative value. So the actual direction is opposite to the assumed one. I2 value is 0.412698. 0.412698. So now we can find the values of currents through all the resistors. Through R1 it is 0.09523, 0.09523. Then through R3, so I1 it is from B to E, I2 is also from B to E, so we have to add it 0.09523 plus 0.4126. So it is 0.50793. 0.50793. Here I1 is from B to E, I2 is also in the same direction, and these currents you will get current through R3. Then current through R2, same. It is I2 0.412698. Current through this 10 ohm resistor R4 is also 0.412698. We got all the currents. There are only four resistors R1, R2, R3, R4. We got the current through all these elements. Now we have to solve this problem by node voltage methods. So we have to find a reference point. Here this is the reference point, which is the ground. Potential at B, let's take it as V1. So assume all outgoing currents, say X, Y, Z. We get a, while solving, if we get a negative value for any one of this or more than one, then we'll reverse the sign. That will be the actual sign of the current. So X, equation for X can be written as, or say E is at ground potential 0. So if we take this path, we have already taken it in the previous example, 10 minus 25x. So there is only one EMF source and one IR drop in this path. 10, it is a rise in potential. I have given a positive sign. 25x, current is from B to A, path is from A to B, so it is to be given a positive sign. So adding the voltage, we will get V1. So equation for x can be written as V1 minus 10 divided by 25. So x is V1 minus 10 divided by 25 and y. So there is only one element in this path. So y is equal to V1 minus 0 divided by 15 or V1 divided by 15. Z can be found from the equation for the third path. So now Z is in this direction. Z is from B to C, C to D, and D to reference. So Z is in a direction opposite to that of the current through R2 as well as R4. Z is in this direction. Here Z is like this. So both are opposite to it. And in this path, the 20 volt is a rise in potential. So I'll write the equation as 10 Z here plus another 20 Z, though I'll write it as 30 Z plus 20, 30 Z plus 20 is equal to V1. Or Z is equal to V1 minus 20 divided by 30. So the node equation is x plus y plus z is equal to 0, or V1 minus 10 divided by 25 plus V1 by 15 plus V1 minus 20 divided by 30 equal to 0 is the node equation. So there is only one unknown here in this equation, which is V1, which we can find by solving this equation. We will get V1 is equal to 7.62 volt, which we already got it in the previous example. So current through R1, it is X. What is the value of X? It is V1, the potential is 7.61 and this battery voltage is 10 volts. So V1 is equal to, I'll write it as 7.62 volts approximately. So x is equal to V1 minus 10 divided by 25, or 7.62 minus 10 divided by 25, you will get it as minus 0.09523. So the direction of assumed direction is not correct. It is in the opposite direction. The magnitude of the current is 0.095237 from A to B. Now next y is 7.62 by 15. We'll get a positive answer. That is 0.507, and this assumed direction is correct. That is 0.5079. Y is 0.507938. Set Set is V1 minus 20 divided by 30. V1 is 7.62 So the current is at the 7.62 minus 20 divided by 30. So that's also negative. So answer is Z is equal to 7.62 minus 20 divided by 30. That is minus 0.412698. Minus 0.412698. So assumed direction is not correct. We have to change the direction. So this is Z equal to 0.412698. So if we add X and Z, it should be equal to Y. That is 0.412698 plus 0.095237. It's equal to 0.507938. So the flow is also satisfied. It is correct. So this direction. So X is from A to B, Z is from C to B, and Y is from B to ground. Next, we have to solve by mesh current method. So in this case, we have to assume three mesh currents: I1, I2, I3. So the three mesh currents are I1, I2, I3. Now the IR drop here is 10 I1. So mesh and loop, the mesh current and loop both are in the same direction. So it is minus 10 I1. Then minus I1 minus I2 into 5. The IR drop in this resistor R3 is I1 minus I2 into 5 with a negative sign. This 25 is a fallen potential, so negative sign. So minus 10 I1 minus 5 into I1 minus I2 minus 25 is equal to 0. So all IR drops are having negative sign because it is a mesh current equation. Direction of loop and direction of current both are same in this case. So 10 I1, then I1 minus I2 into 5, both are having negative signs. Then second mesh equation, this 20, this is the clockwise, the loop is in clockwise direction. So in clockwise direction, the voltage 25, it's a rising potential, so plus 25. Then current through R3 is I2 minus I1 with a negative sign. So IR drop is minus 5 into I2 minus I1. Then 10 I2, negative sign. Then current through R5 is I2 minus I3 with a negative sign. So minus 10 into I2 minus I3 is 0. Then third loop, current through R5 is I3 minus I2 with a negative sign. So IR drop is 10 into I3 minus I2 with a negative sign. Then current through R4 is I3. So 15 I3 is the IR drop with a negative sign. Here it is a fallen potential in the direction of the loop. This 50 is a fallen potential minus 50. So first equation can be simplified to minus 15 I1 plus 5 I2 is equal to 25. Then second equation can be simplified to minus 5 I1 minus 25 I2 plus 10 I3 is minus 25. Third equation can be simplified to 10 I3 minus 10 I2 minus 25 I3 is 50. So in matrix form, There is no I3 term here. So minus 15, 5, 0. Here it is 0 because there is no I3 term in the first equation. Second equation, I1, I2, I3 are having coefficients. So 5 minus 25, 10. 5 minus 25, 10. 5 minus 25, 10. Here minus 15, 5, 0. Minus 15, 5, 0. Third one, I2, I3, I1 is not there. So it is 0, 10, minus 25. 0, 10, minus 25. It's equal to 25. This is 25. Then minus 25. Then 50. So I1, I2, I3 is inverse of this matrix into 25 minus 25, 50. So I1, I2, I3 is equal to minus 15, 5, 0, 5 minus 25, 10, 0, 10 minus 25 into inverse of that into 25 minus 25, 50. Find the inverse of this matrix, multiply with this vector. So you will get it as I1 minus 1.72, I2 minus 0.17, I3 minus 0.20. So all assumed direction will reverse. So I1, I will write the value. For I1 is minus 1.724. So 1.724 ampere. I2 is 0.1724. I3 is 2.068. And I have to reverse all the directions. So these are the, now what are the currents through different resistors? R1, it is 1.724. Just check what the, 1.72. Correct. 1.724. Then R2, this is the current. That is 0.1724. R3 is I1 is flowing up, I2 is coming down. So it is 1.724 minus 0.1724. This is the net current through R3. 1.724 minus 0.1724 is equal to, that is flowing from flowing out of the 25 volt battery. So it is resistor R3 1.5517. This current is 1.5517. So 1.72 is flowing up and 0.1724 flowing down. So the net current is 1.5517 flowing upwards. Now next, the current through R4, it is 2.068 flowing like this, 2.068. This current also will mark 0.1724. This current is 1.724. Now the current through R5, It is 2.6068 down and 0.1724 up, 2.068 minus 0.1724. 2.068, 1.8965. So 2.068 like this, 0.1724 upwards. So 1.89 in this direction, 1.8965. Now we can check whether the law is getting satisfied at all the nodes. 2.068 is coming to this junction. Let's mark it as A and B. 2.068 is coming here. 1.89 is moving down, flowing down. The remaining is 0.1724. So 1.8965 plus 0.1724 is 2.068. Then here coming up 1.5517. This is 0.1724. So this is an outgoing current. Add these two, 1.5517 plus 0.1724 is 1.724. So the law is getting satisfied. So these are the currents. So next example is write the node voltage equation, hence find the branch currents. There are two nodes in this case, V1, V2. This is the reference. So this current is V1 minus reference node has 0 volts. 0 volts. So V1 minus 0 divided by 10. So V1 minus 0 divided by 10 plus V1 minus 25 divided by 5 plus V1 minus V2, that is this current, divided by 10 is equal to 0. Again for node 2, this is node 1, this is node 2. This current, that is V2 minus V1 divided by 10 plus the current in this branch V2 minus 0 by 10 or V2 by 10. Then current here in the branch connected to 50 volt battery, V2 minus 50 divided by 50 plus V2 minus 50 divided by 15 is equal to 0. 1 second. So first node equation, that is current through the 10 ohm resistor, that is V1 minus 0 divided by 10. That is the current, this one. Say take it as X. This is Y. Z. This X1, Y1, Z1. Let's assume like that. So X is equal to V1 minus 0 divided by 10. Y is equal to, X is equal to V1 minus 0 divided by 10. Y is equal to V1 minus 25 divided by 5. And Z is equal to V1 minus V2 divided by 10. Next node equation, second node equation. X1 is V2 minus V1 divided by 10. That is this one. Then Y is V2 minus 0 divided by 10 or V2 by 10. Z1 is equal to V2 minus 50 divided by 15. So these two can be V1 by 10, V1 minus 25 by 5, V1 minus V2 by 10, V2 minus V1 by 10 plus V2 by 10 plus V2 minus 50 by 10. You can solve this equations, and the answer is V1 is 17.24. V1 is 17.24 volts. V2 is 18.965. So the branch currents are, just substitute it, 17 minus 0 divided by 10. 1.724 is the value of X. This is 1.724. 17.24 divided by 10. This is 17.24 minus 25 divided by 5. Its value is 17.24 minus 25 minus 1.5517. So y is opposite, in the opposite direction. Value is 1.5517. Z is equal to 17.24 minus 18.96 by 10. Obviously, Z is equal to, Z is 17 months. So it's a negative quantity. Sign is not correct. Reverse it. 17 minus 80 by 0.1724. This is 0.1724. X1 is also the same, V2 minus V1. So we don't have to calculate it again. It is 0.1724 ampere only. That is X1. It's 0.1724. So you can check 0.1724 is coming to this junction. 1.55 is also an incoming current to the junction. 1.55 plus 0.1724 is 1.724, which is the outgoing current from the junction. First node. Second node, this is 0.1724. Y is 18 minus 6 divided by 1.8965. That is correct. 1.8965 coming down. So Z1 can be found by adding these two. This is outgoing, this is also outgoing. So Z1 is an incoming current. So Z1 also 18.965 minus 50 by 15. 18.965 minus, that is 2.069 is the value of current. 2.069. It is negative, so sign is opposite. Sign is in this direction. Again, you can check 1.8965 plus 0.1724 is 2.069. 1.8965 plus 0.1724, that is this current, is equal to 2.069. So we got all the branch currents. So that's all for today's session. Thank you very much for watching this video. Please share it among your friends. And don't forget to subscribe for the channel.